Hi everybody, please turn to page 33 for your ratio and proportion notes. So we're going to start today looking at the definition of ratio. Here's what I'd like you to write in this spot. A ratio is a relationship. It's a relationship that compares two quantities. So one example could be, I could say that there are three laptops for every one classroom. So that's what one ratio could look like. I could also write it in the form of a fraction, so I could write 3 laptops for every one classroom. So let's see how ratios can take shape in a math problem. So our first question says, the perimeter of an isosceles triangle is 56 centimeters. The ratio of LM to MN is 5:4. Find the length of each side. So the first thing I'm noticing is that they said that there's an isosceles triangle, and isosceles means that two sides are equal. Now, since these two base angles are congruent, that would mean that these two sides are equal. Now, they also said that our side lengths, LM to MN, LM to MN, are in the ratio of 5:4. So one way to think about this is we could suppose that this side is 5, and this side must also be 5 because it's an isosceles triangle, so those two sides are congruent. And this side is 4. So 5 centimeters, 5 centimeters, and 4 centimeters. Well, they gave us that our perimeter was 56 centimeters. Now, if that's the case, these measurements wouldn't work. For sure, LM is in a ratio of 5:4 for LM to MN, but 5 plus 5 plus 4 is not 56. That means that there's some multiple of this going on, but I don't know what it is. What could the multiple be? Well, when we don't know what that mystery value is, we might as well just put an x here. That means that 5x plus 5x plus 4x, if I added those values together, that would give us our mysterious perimeter of 56. But we don't know what that multiplier is. That means that 14x equals 56. And if you were to divide by 14, you would get x equals 4. So if I wanted to find the length of each side, I could tell then that 5 times 4 would be 20 centimeters. 4 times 4 would be 16 centimeters. And this, I don't even have to do the math, it's congruent, so this would be 20 centimeters. And just as I would see, 20 plus 20 plus 16 is 56 centimeters. That's how we found our length. So let's move on to example 2. For this problem, it says the ratio of the angles of a triangle is 3:4:8. Find the measure of each angle and draw a picture. So we can draw this. Let's imagine we have a triangle, and I know that the angles are in a ratio of 3:4:8. Okay, so here's one possibility. This angle could be 3 degrees, this angle could be 4 degrees, and this angle could be 8 degrees. Well, that's not going to work because I know that the sum of the angles should be 180 degrees. Well, that means that there's some multiple of this ratio. So we could call this 3x, 4x, and 8x, meaning that in order to find what those angles are, I would know that 3x plus 4x plus 8x equals 180. And if I solve for x, I could find the actual measure of each of those angles. So let's see. 3 plus 4 is 7, plus 8 is 15x, equals 180 degrees. And if you divide by 15 on both sides, you'll get that x equals 12. So they asked us to find the measure of each angle. Then that would mean this is 8 times 12, so 96 degrees. This is 3 times 12, so 36 degrees. And this one right here, this angle is 4 times 12, or 48 degrees. and if you added all those angles together, they would add up to 180 degrees. So now, we're ready to talk about what a proportion is. A proportion is, here we go, a proportion is when two ratios are equal to one another. Now, if you recall, a ratio is really just a fraction, right? A comparison of one value to another. So one example of a ratio might be 1/2, so 1 to 2, one dog to 2 cats, let's say, is equal to, let's say, 4 dogs to 8 cats. So really a proportion is a set of equivalent fractions. So we're going to use what we know about proportions and the definition of a proportion to look at a couple properties. So one of the most common properties that we know is that if you have the proportion A over B equals C over D, then you can also say that A times D is equal to the quantity of C times B. So that's essentially saying that the values that are across from each other, the numerator and the denominator of opposite ratios multiplied together, is equal to the product of the numerator and denominator of the opposite ratios. So let's go ahead and draw a line here. Here's another thing that you could write. If you have the proportion A over B equals C over D, then you could also say that A over C is equal to B over D. Okay, so that's saying that if you have this same proportion, that the ratio of the numerators is equal to the ratio of the denominators. One more property. Last one is if you have that same proportion, A over B equals C over D, then lastly you could say that B over A is equal to D over C. Here we're saying that if you reversed the numerators and the denominators, and you put the denominators in the place of the numerators and the numerators in the place of the denominators, those ratios would be equal also. Now there are more properties for proportions, but these are probably the most arguably powerful. And I would say that really properties of proportions are really properties of fractions, so keep that in mind. Now we're going to use these properties to solve some problems. So let's take a look. Go ahead and turn the page, and we're going to take a look at example 3. So example 3 asks true or false. So the first thing they're asking is if this is true. So if this is true, this proportion is true, then is this proportion also true? Now I tend to use this property the most, where I check to see if the product of the numerator of one ratio times the denominator of the other is equal to the numerator of the other ratio times the denominator of the other. So let me show you what I mean. So they're saying that this is true. So for part A, if x over 10 is equal to 15 over t, well then what can I say? Then I can say that x times t is equal to 150. Where'd the 150 come from? 10 times 15. So now they're asking if this is true, if x times t equals 150, which came from this proportion, is this also true? Well, let's check it. So I'm going to check this. So they're saying x over t equals 15 over 10. Let's see if this is equivalent to what we got. That would be 10 times x is equal to 15 times t. So I guess I ask you this question: is this equation the same as this equation? They're not. That's why I can conclude that for A, this is a false statement. So now to check my part B, I'm going to need a little bit more space, so I'm going to move this over here. So for part B, they're saying that if this is true, so for part B, they're saying if 3 over x equals 5 over 4. Okay, so let's see what these products would equal. I would get 5 times x equals 12. So I'm getting this product equals this product. Let's see if that equals, I have 3 plus x over x equals 9 over 4. I'm going to move over just a teensy bit more. Alright, let's see if this product works. Now I'm going to do 9 times x, that's easy, that's 9x. But I'm going to do 4 times this entire quantity. That's 4 times this entire quantity. So now I'm going to use the distributive property to get 12 plus 4x. I'm going to subtract 4x from both sides to get 5x equals 12. And that's where I automatically notice that something happened here. I've just shown that the proportion on the left that they gave me was the same as the proportion that they gave me on the right. So to recall, they said, if this is true, is this true also? If this is true, then this is true? Yes. 5x plus 12 is equal to 5x plus 12. This is a true statement. Alright, let's go back to our example 4. So now for example 4, they're asking us to solve. So I've got x minus 5 over 4. Let me draw this line here so we can see that that's a change. X minus 5 over 4 equals x over 8. If I want to solve this, I'm going to go ahead and look at my products. I would get 4 times x equals 8 times x minus 5. Alright, that means that 4x is equal to, I'm going to distribute 8x minus 40. I'm going to subtract 8x from both sides to get negative 4x equals negative 40. And when I divide by negative 4, I get x equals 10. Okay, x equals 10. So now on to example 5. For example 5, here's what it says. A picture is 2 centimeters wide and 7 centimeters long. Okay, so I'm going to draw this picture here. I've got a picture that's 2 centimeters wide and 7 centimeters long. If I want to enlarge the photo, so the width is going to change to 43 centimeters. So now I've got this larger picture that's now going to have a width of 43 centimeters. And now they're asking, what would the length be? That's why I'm putting an X here. I don't know what the length would be. Now, we know that the sides are proportional, that there's a relationship from 7 to x and from 2 to 43, a scale factor. And those proportions should be equivalent. So if I set up my proportion, let's see, 7 goes to x and 2 corresponds to 43. So I want you to make sure you saw that 7 corresponds to x. Those are both the length, small to big, and 2 to 43. Again, the corresponding lengths. Now, once you set up that proportion, you can solve. So what do we get? 7 times 43, I'll be your calculator, is 301 equals 2x. So just as a reminder, I'm doing 7 times 43 equals 2 times x, which is 2x. When I divide by 2 on both sides, I'll get half of 301, which is 150.5. And in this case, since it's our length, we're going to say that it's 150.5 centimeters. Make sure you add your units. Now on to example 6. Okay, in this problem they've given us a triangle TSU, and a side length of m and a side length of 3m plus 6. Now what's given is that SU and ST are in a ratio of 4 to 1. Now remember, a ratio is the same as a fraction. So SU to ST is in a ratio of 4 to 1. And they want us to find m. Well, luckily, they've given us SU. SU is actually 3m plus 6. And I know what ST is, it's m. So if I wanted to solve this proportion, I could actually find m and actually find the lengths if they had asked that. So I'm going to go ahead and do my math here. I'm going to multiply 4 times m to get 4m equals, and then I'm going to multiply 1 times 3m plus 6, 1 times 3m plus 6, and once I distribute, I get 4m equals 3m plus 6. Distributing a 1 doesn't change that quantity within the parentheses at all. Now I'm going to solve for m, so I'm going to subtract 3m from both sides to get m equals 6. And just like that, we found what m was. So now we're down to our last example. In this problem, they've given us another triangle that has been cut in the middle, and they're saying that MQ over NQ, MQ over NQ, so one entire length of the triangle versus the smaller side length of the triangle, is equal to LQ, so one whole side, over PQ, the right-hand side. And they're asking us to find LQ. All right. I'm going to go ahead and write that proportion down. So MQ over NQ equals LQ over PQ. Let's substitute some values in here. What is MQ? MQ is not just 15, and it's not just 6. It's this entire length. So 15 and 6, that's 21. All right, how about NQ is 6? That's this little piece right here. That equals LQ. Okay, that's this entire length. So it's not just X, it's not just 5. It's these two values put together. Now think about what we did here. I said it wasn't just 15, it wasn't just 6, it was 21. What did we do with these two values? We added them. We did 15 plus 6 to get 21. So if I want to find this whole length, I'm going to have to add these two together. That's why we'll say that LQ is X plus 5. And PQ is 5. Now solving for X should be easy, but just keep in mind they asked us to find LQ. So once we find X, we'll have to do some calculations. So I'm going to go ahead and multiply across. So I'm going to get, and I'll start up here, 21 times 5 is 105, and then I have 6 times the quantity x plus 5. So I'm going to go ahead and distribute that 6 to get 6x plus 30. And when I take 105 and I subtract 30 from it, I'm going to get 75 equals 6x, and when I divide by 6, I get x equals 12.5. Now remember, they asked me to find LQ, and LQ is this entire length. So I'm going to need to figure out what x plus 5, that's what LQ is, would be. In this case, 12.5 plus 5, or 17.5. We'll say units because they didn't give us a measurement. So 17.5 units is what LQ is.